Good day! We are going to talk about the introduction of conic sections, functions, and piecewise functions. First of all, what is a double-knob circular cone? It is the shape formed when two congruent cones put on top of each other, their tips touching and their axes aligned, with each are extending indefinitely away from their tips. Parts of a double-knob circular cone. We have central axis, generators, vertex, upper and lower naps, and vertex angles. Out of this, the three degenerate conic sections are a point, single line, and two intersecting lines, while the non-degenerate conic sections are circle, ellipse, parabola, and hyperbola. The type of conic section can be determined using this equation, the general form of second-degree equation, and the value of the discriminant b squared minus 4ac. Refer to this table. For example, x squared minus 4y squared plus 5x minus 8y plus 16 is equals to 0. Refer to the general equation of second-degree equation to get the values of a, b, and c. A is equals to 1, b is to 0, and c is to 4. Substitute them to get the value of the discriminant. The answer will be 16. Since it is greater than 0, the type of conic section is a parabola.
Now, let's move on to functions. So, what is a function? A function is the rule of relationship between an input, independent quantity, and an output, the dependent quantity, in which each input uniquely determines one output value. Functions can be represented by either table values, mapping, or arrow diagram, a graph, or by listing method. The domain, or X, is the set of inputs. The codomain is the set of all possible outputs, while the range, or Y, is the set of outputs. There are different classes of function: injective, surjective, and bijective. Injective is also called one-to-one. Surjective functions are onto functions, while bijective functions are both one-to-one and onto functions. The vertical line test determines whether a graph is a function or not. It is a function if there are no vertical lines that intersect the graph at more than one point. The horizontal line test determines whether a graph is injective. If a horizontal line intersects the graph more than once, then the function is not injective. Here are the types of functions: constant, linear, quadratic, polynomial, absolute, and piecewise. The constant function is denoted by f of x is equal to x. The domain of all functions is negative infinity and positive infinity, or all real numbers. The range of constant functions is the constant itself. Linear functions are denoted by f of x is equal to mx plus b. The range of linear functions is negative infinity to positive infinity, or all real numbers. Quadratic functions are denoted by f of x is equal to ax squared plus bx plus c. To get its range, the vertex must first be identified. The table of values can be used, or the formula negative b squared over 4ac. Polynomial functions are functions of a single independent variable, in which that variable can appear more than once, raised to any integer power. Absolute functions are functions that contain an algebraic expression with an absolute value symbols.
Now we move on to the piecewise functions. A piecewise function is a combination of one or more functions. The rule for a piecewise function is different for different parts or pieces of the domain. For example, V's piecewise function is given. You are asked to evaluate -4, -1, 3, and 4. This is your domain set. Evaluate these one by one. For each, identify to which restriction it belongs. Let's try x equals -4. We need to check if it belongs to the first function. This function tells us that x is less than or equal to -3. We know that -4 is less than -3, so this function will be used. Substitute -4 to x, -4 plus 1, -4 plus 1 equals -3. Let's try out another example. X equals -1. Let's analyze which function the given value of x belongs. In the case, it belongs to the second function where x squared minus 3. Substitute -1 to the variable x of the equation, which will be -1 squared minus 3. Following PEMDAS rule, square what's inside the parenthesis. -1 multiplied itself by -1 is equal to +1 minus 3 is equals to -2. What if the given value of x is +3? Where do you think will it belong? Oh, on the third function, -2 plus x, applying 3 in the variable of x, -2 plus 3 equals 1. For our last example, 4 is the given. It's the given number. Analyzing which function it belongs, it appears to the third function again. Substituting again will give us an equation of -2 plus 4. Adding it will give us an answer of +2.
We now have our sets of points. To make a graph for this function, more x values must be used and evaluated. So this concludes our discussion about conic sections, functions, and piecewise functions. Hope you learned something, and remember, don't lose hope in solving math.